So this is a short lecture on a short introduction on just single stage CMOS amplifier, which we will talk about in our next discussion. So in the previous video, we discussed the analog octagon, right? Or analog design octagon, and few things which are important in this octagon you saw, of which we can already jump into. The gain we have seen in detail, but as I told you that in the design, along with the gain, there's the importance of input-output impedance, right? Because you are going to interface this uh, these circuits with the real source and load. So that is, so we'll look at different quantities in the octagon one by one. So as of now, let's just look at these two variables. We have gain and we have input output impedance, right? And the configuration we are looking at is again, there's a gate drain source, right? And there can be multiple configuration for this, right? So the one which we have talked about quite a bit is this configuration where we see the source is grounded, right? And you're applying an input to the gate and taking the output to the drain, right? That is what we have talked about. And we have also talked about different kind of loads, right? So we have started with the ideal current source load to active load, and even we talked about the CMOS inverter push-pull kind of configurations. So for now, just to keep things simple, we can assume that there's no effect of load. So we can assume a kind of an open circuited transistor, right, for gain and calculating for a gain and the input output impedance, right? So what we are interested in, we are interested in AV, which is your small signal gain. We are interested in input impedance, which is nothing. It's again when you are applying a signal and how much is current passing. So which is V in divided by I in, right? And we can also look in the same way from the output, that this is V out and there's a current flowing, if, right, that would be R out would be V output divided by I, right? So these are the three variables initially we can look at, and we look at all other variables one by one in the octagon, because if we look at once, it can be overwhelming, right? So we will first understand one by one. And for simplicity, we are just taking an open circuit configuration. So that means our load in small signal, or you can consider it like a ideal current source, where in the small signal analysis, this is open circuit, right? So now, if a common source we have calculated, right? So the gain, you can just draw the small signal for this, but we have already calculated. This comes out to be GM by JDS, right? What is the input impedance? RL. So when you're applying a small signal voltage Vn, there's a small signal current flowing, right? What is this? So as you know, this is the gate resistance, which is typically tending to infinity, or it's very high, right? There's nothing called infinity, just very high. Because we apply small signal, there's a current definitely which flows into the gate. Because of the dielectric, the small signal current is very small. So that is why this comes to be very high. Now, what is the output impedance? This is also straightforward because it's a open circuit configuration of the constant current constant current source load. So when we see the current is going to flow directly through here. And when we calculate the output impedance, obviously our input is shorted, right? Because we only apply one excitation at a time, right? So your input is shorted, and then when you see, you get, so this comes out to be 1 by GDS or R naught. So this all can be looked at very simply from this small signal analysis of this circuit, right? But why to stop on the circuit? So you can try. So there's 4, right? I can, rather than just the gate, drain, and source, I could also think, because one of them I have to make a reference, but I could also think of a configuration where gate is a reference, right? And source is where you apply a input, and drain is where you are taking a output, right? This could be another configuration where the gate is, so this is in a small signal, just grounded, right? So this is obviously AC ground we are talking. So you have to find out for this circuit what is the gain, your Rn and R. Okay. Similarly, I could also have a configuration. So this is this circuit, or this configuration is called, it's a common gate, right? Because there is a gate is applied to a fixed potential. Similarly, here source is applied to a fixed potential or zero. It's called common source. And there's another terminal which is can be common as common drain. So that means this can be another configuration, right? Which is, this is obviously grounded. Then you have V in applied here at gate and V out. For this also, using the same small signal, you calculate this is your common. Okay. So this would be the starting point for us for the next discussion, which we are going to have on single stage amplifier. And in this particular analysis, by this you could be able to look at the amalgamation of, let's say, with the simple circuit, by changing the input output node, how does the gain, input impedance and output impedance changes, right? So that would be very interesting to see from the first point of view. Then we'll play with the load and we'll connect other things into these configurations.